All right, but today we're looking at simplifying square roots. So really there's three steps you can kind of think of. The first one is you're going to make, it's called a prime tree, or you're going to do like a factor tree. So different, depending on who you like, who's saying it, they might say slightly different. Step two, we're going to, once we write out our prime tree, we're going to circle pairs. And then the idea is pairs come to the outside. I call them the leftovers. The leftovers go underneath, or go. I'll say go on the inside. Or here, I'll just put inside. Okay. A few things before we get started. If you don't know, like before we look at our examples, one thing is, if you don't know, I don't know how much you guys know about prime numbers, but prime numbers are basically numbers that you can't break them down anymore. Like basically the only things that divide into prime numbers are one in itself. So I'm just going to list, I can't list all the numbers because there's an infinite amount, but like some prime numbers, like start like the smallest ones, 2, 3, 5, 7, 11, 13, 17, dot, dot, dot. Keeps going. But like all of these numbers, like for example, can't be broken down anymore. Like the only, like 2 is the only thing that makes up 2 is 2 times 1. The only thing that you could break down 3 would be 3 times 1. So our goal is, when we're doing our like prime tree or our factor tree, is that we want to break down our numbers as much as we can until we get primes. So like for example, I'm going to erase this, but 8 would not be a prime number because we could break that down as 4 times 2. You know what I mean? So basically prime factor tree, like basically what we're doing is we're just trying to break down the numbers until we can't anymore. One other thing I wanted to say before we start, this check mark looking symbol, or like the square root symbol, like that symbol is called a radical. Like, so because we'll be looking at different types of roots or different types of radicals in here. So if I ever say like put it underneath the radical, or say put it underneath the root, or say put it underneath the square root, I mean the same thing. So a radical is that check mark looking symbol like that. That's radical. Okay. So let's just look at some examples. Let's kind of see how this works. So I'll do a few, and then I'll have you maybe try a couple, and then make sure we're good. Tomorrow you'll have an assignment where you'll practice this for another grade, get some more grades in case you're trying to pull your grade up. So the first thing you want to do is you want to think of 2 numbers that multiply to give you what's underneath. So some people are pretty good at just seeing it like, oh, this times this gives me 50. But if you ever are struggling, or if it's just maybe it's a big number, you can always put it in your calculator, like try dividing numbers into 50. So like, for example, you could do like 50 divided by 2. If you do that, that would be 2 and 25. But you could do, there's like, as long as you're mathematically correct, it doesn't matter what you put there. Like, for example, you also could have started with 5 and 10, because 5 times 10 is also 50. But you're always multiplying, like these numbers that you come up with should always multiply to give you what's above it. You're always multiplying, you're not adding, nothing like that. So 2 is a prime number, so that's done. But 25 we can break down more. 25 is 5 times 5. And then 5 and 5 are prime numbers. So sometimes it's helpful to just take what we have. So we had 1, so we write our radical, and we had 1, 2, and then we had 2 5s. So we write these underneath the radical, multiply together. Like if you multiply 2 times 5 times 5, you would get 50 back to where you started. So we just kind of write those, like, because once you break down a number, like we're not looking at that 25 because we broke it down. So we're really just looking at 2, 5, and 5, like the most bottom part of our tree. So Mrs. Walkoff has an analogy to kind of help us remember how we do steps 2 and 3. So the first thing we're going to do is circle any pairs. So we got a pair of 5s. So how Mrs. Walkoff explains this, and it's kind of strange, and it's, I don't know, maybe it's kind of dumb, but it's stupid enough it might help you remember how this works. But she calls this, they're in radical jail right now. Like the 2, the 5, and the 5, they're in radical jail. To get out of radical jail, you need a partner to break out. You can't break out by yourself. So you need an accomplice to break out of jail. So, but when these 5s break out of radical jail, one of them gets shot. So there's only one left. So basically for the pair, you pull one to the outside, and then you still have the 2 left in jail because you didn't have a friend to break out with. So when you pull out a pair, you only pull one to the outside from each pair. So if it's helpful to write it underneath the radical, I'll kind of show you. If you don't want to write it all underneath the radical, you can just kind of pull it from your tree. It's up to you. But that would be our simplified radical answer. A lot of times if you take like an ACT test or something, they might leave their answer like this. You could always put it in your calculator and turn them into decimals, but sometimes it's nice to be able to keep your answers in radical form, just so you don't have to deal with messy decimals. So let's look at another one. So we want to break down 200. So you want to ask yourself, or you want to come up with 2 numbers that multiply to give me 100, or sorry, 200. So you could start dividing numbers in your calculator, or some of you guys are going to see it right away. Like, for example, you could do 100 times 2, or you could have done 20 times 10, or 50 times 4, or like I said, it doesn't matter how you start, because once you break it all the way down, you're going to get the same numbers. So as long as you're mathematically correct, it shouldn't matter. 100, you could just keep cutting it in half. It'd be 50 times 2. Oops. Or you could do 10 and 10 even if you saw that. So then we could keep breaking down the 50. Maybe 50, I'll do 5 and 10. We're a little low on space, but the 10 would be 5 and 2. So one thing that might be helpful when you're starting, though, is like once you break down a number, you don't look at it. So we're not looking at the 100 because we broke it down. We're not looking at the 50 because we broke it down. We're not looking at the 10 because we broke it down. And then the numbers that are left, like we can't break down 2. You never want to put a 1 in your factor tree. Like you're not going to do 2 times 1, like, because you can just keep doing that forever. So 2 can't be broken down, 5 can't be broken down, because those are called prime numbers. Like they can't be broken down. They're kind of like the building blocks of all numbers, if that makes sense. Like every number can be built up from these primes. So if it's helpful, you can write these all underneath our radicals. So I like to keep them together. So we have 2 5s, and then I had 3 2s. So we want to circle our pairs. So I got a pair of 5s, I got a pair of 2s, and then the 1 2's left out. No friends for him. So from each pair, you pull 1 to the outside. So we're going to have 1 5 on the outside, and we're going to have 1 2. You just pull 1 number out of each pair, and then you had the 2 that was left underneath. When you pull more than 1 number to the outside, you multiply them together. So 5 times 2 would be 10 radical 2. And if you have a calculator, like for example, if you put in the square root of 200 and you put in this 10 square root of 2, you would see it's it's the same thing. It would be about, I think, it'd be about 14 point something, I think, if I'm not mistaken. But yeah, you would see they are the same, like these answers.
So, but I have a question.
Yeah.
Okay, so for the first one, don't you know how we?
Next one. So looking at problem 3. So we want to just break it down. So what would multiply to give us 48? One tip, if it's an even number, you can always do 2 and cut it in half. So like half of 48 would be 24. Because usually it's pretty easy to cut numbers in half in your head. If not, you can always just put 48 in your calculator, start trying to divide it by numbers until you don't get like a decimal. Like for example, if you did 48 divided by 2, you would see it's 24. So 24 and 2 would work. Here, I'm going to actually write that just a little bit smaller. We could keep doing that. Like we could keep cutting it in half. So that would be 2 and 12. That would be 2 and 6. And then we could do it one more time. So that would be 2 and 3. And like I said, you don't have to like cross them out, but it might be helpful. Like once you break something down, you're not looking at it anymore. So like we're not looking at those numbers because we broke them down, but we have a 2, a 2, a 2, a 2, and a 3. So if you want, like usually I just write it underneath my radical. So we have what, 4 2s and 1 3. So then you could circle your pairs. And then the 3 is left by itself. So since we have 2 different pairs of 2s, we're going to pull out a 2 from the first pair, a second 2 from the second pair, and then the 3 is just left underneath the radical. So this would be 4 radical 3. So each pair pulls one number to the outside. So that's why we had 2 2s there. How about you guys try number 4? See if you can come up with an answer for that one. If you want to write it in the chat, I'll put in the chat maybe how you could type it. I know you can't type like a square root like in the Zoom chat. But how about you guys see if you can do number 4? Let's see how this is going. All right, so then these last two problems, there's nothing too different other than there's a number or there's like a constant already on the outside. So we're not gonna, the only thing that's gonna change, and I'm just gonna erase just that so it's not in the way. The only thing that's gonna be different is we start with the 2 on the outside. So we're just gonna do our factor tree like we normally would. I don't know how well you guys are at seeing this, but 9 times 6 is 54. If you're not sure, you could divide in your calculator. You could have done 2 and 27. That would have worked as well. But 9 is 3 and 3. 6 is 3 and 2. So like we broke down these numbers, so we're not looking at those. I personally like to just look at my tree. So like, for example, I got a pair of 3s. So I could just pull the 1 3 to the outside. These numbers here don't have any pairs, like the 3 is by itself, the 2 is by itself, so they're going to stay underneath my radical. So I'm going to have a 3 here and a 2. So then we just got to multiply these out or clean it up a little bit. So this would be 6 radical 6. And then let's just look at this last one quick. And you'll have a chance, like I said, tomorrow you'll have an assignment.
Well,
Yeah.
okay, so number 5, I'm confused on how it was 2 times 3 outside the radical, then 3 times 2 inside the radical.
Okay, well, one thing is order, if you had them like swap, the order is not necessarily important. So it's, if you had it swap, that's not a mistake. But the first 2 on the outside just came from the original problem. So that's where that 2 came from.
Okay, and we don't use the 2 3s because they're identical.
Yeah, like when you get a pair, like when we circle a pair, we just put 1 3 on the outside.
Okay.
Because the reason is, like the square root of 3 times 3, that's really the square root of 9, or just 3. So like that, those 2 3s really turn into 1 3 on the outside, if that makes sense.
Okay.
But yeah, anytime you have a pair, you just pull one number to the outside from the pair.
Okay.
So for problem 5 though, oh, the second number 5, so actually it should be number 6, but we have a 2 on the outside to start with from the problem. So then we're going to break down that 48. So did we already do 48? Yeah, like you could honestly look at number 3. Like, I mean, it's the same number. So we did, I'll just copy that tree. It's actually just 2 and 24, 2 and 12, 2 and 6, and 3 and 2. So we've got 2 pairs of 2s. And then we have a 3 that's left by itself. Because remember, we broke down the 6, we're not looking at that. We broke down the 12, broke down the 24, so we're not looking at those. So I already had a 2 from the original problem. Since I have a pair here, I'm going to pull out another 2. And then since we had a second pair, like this pair here, I'm going to pull out there's going to be 3 2s. So there's 2 from the 2 of the 2s came from the pairs. The 1 2 just came because there was a 2 on the outside to start with in this problem. And then the only thing we had left over in this problem was the 3. Like it didn't have a pair. So 2 times 2 times 2, that would be 2 times 2 is 4, times 2 would be 8, and then radical 3.